Well, happy new year to you, Noor Daraiseh. Thank you so much for joining us today. We are so excited to talk with someone. We oftentimes have a lot of boys in our group, and we have a few girls as well. But anytime we get a girl in STEM, it's really, really exciting for all of us. So share with our audience a little bit about who you are and how you came to get involved in a STEM field.
Thank you so much for having me. So as you know, my name is Noor Daraiseh. I am a student at the Florida Institute of Technology. I study oceanography as my major. STEM has always been a big part of my life, even when I was a little kid. Um, I remember in like the third grade, we had a career day thing where it's like you go up and you talk about like what you want to do as a job, and they had an option where you could like dress up first like as your job. And so that day I went home like right away and I was like, Dad, I want to be an astronaut. And so we made like a huge paper mache helmet and like we got a painter suit and put the NASA sticker on. And so ever since that day, I do remember like I was so excited to be just in STEM. I did want to be an astronaut for like the longest time. Um, but I did get into oceanography a little bit later, like in my years of high school, because I thought that it was more of like an undiscovered type of research that I wanted to do. And I thought that discovery was just the coolest thing ever. So STEM for me is super important because I value like education very much. So with the STEM field, it teaches you not only like facts and things and just knowledge about the world, but it teaches you how to think. So I believe it is super vital for people to, be educated and learn, how to analyze, how to observe the world around them with, not only with their mind, but also with their heart and kindness and, be able to appreciate what's around them. So as a woman in STEM, I feel that it is really important for us to be, represented. As you know, a lot of STEM fields like, engineering, like construction, like all that is very male dominated. And I feel like now more than ever, people are starting to realize, hey, a woman can do this too. All the heavy math, all of like the building, the hands-on learning experience, we are also just as capable of doing that. And so I believe it is important to not only engineering, but also, oceanography, like marine sciences. We like to get our hands dirty too and like go dive in the ocean and things like that. So it is super awesome for me to be able to be a part of that.
Now, I know that you grew up in Flint, Michigan. How did you end up getting to Florida Institute of Technology?
So when I was researching colleges, I wanted to be somewhere near the ocean. I wanted to be, right hands-on with like my experience. And, being born in Flint, water was a super important issue to me. Like I was seeing my family like having no clean water, having to get like truckloads of water bottles, and sometimes we couldn't even shower um, with the normal water because it was just so bad. And so that kind of inspired me to be like, okay, I'm going to make a change in this. I don't know how, I'm going to make a change. So I looked up colleges for oceanography, and I stumbled upon Florida Institute. And I thought they had a super awesome, like very liberal arts kind of college because it's super small. And they also had like hands-on research. Like as a freshman from day one, you can go and do that. So that really inspired me. And that's how I decided to end up there.
Well, I met you because recently I took one of my Earth space classes to tour the campus at Melbourne, and you are a student ambassador. So you actually were one of the young women that led the tour, and that's how I was really impressed with you, and that's why how we actually met. I want to go back to something you said earlier. It seems like at an early age you had support from your parents for what you wanted to do when you describe your dad helped build the helmet for you. I think a lot of kids, you were fortunate, right? Because a lot of kids don't have that support at home. So that's very cool. I also want to point out that you mentioned the mysteries and there's so much we don't know about the oceans. And I'm pretty sure that the oceans are a great analog for space exploration because we know so little. And it's such an inhospitable environment, right? If you want to go down there and do that. Do you do any, are you a diver? Do you snorkel? How do you get your hands dirty in the world of oceanography?
Yeah, so recreationally, I do love snorkeling. Um, I love just kind of seeing the the life underneath the ocean, even though it's like close to the surface. That gives me new inspiration every time I do it. I am about to apply to be scuba certified. It's something that I definitely have in my near future, which I'm excited to do. Um, and in terms of educationally, I'm fortunate we're at the school. We have a lot of hands-on labs. So I had a lab this past semester where we went to the Indian River Lagoon on a boat, and we would take water samples or sediment samples from the lagoon, and then we would test those to see kind of like the health of a lagoon, like what's in it, what is in the sediments, you know. And that was interesting to me because I was thinking like, oh, the Indian River Lagoon is like just a regular body of water. It's probably like sand on the bottom. And then when we pulled out like these sediment samples, it was like it felt like I was dipping my hands in like a bucket of paint. It was like so black and like mucky, things like that. So that was kind of like really interesting to me because I was like, okay, this is not what I expected. Why is this happening? So if I get a chance to take some samples, like whether or not they're dirty or not, I'm excited to do that.
Right.
Yeah.
Do you see evidence of human runoff and human pollution even down in that sediment in the Indian River?
Absolutely. So much of the Indian River Lagoon, the sediments are covered in what's called muck. It is about 10% organic matter, 70% water by weight, and the rest are all like nutrients. So you have all of this muck that's coming from like decomposing organic matter from like algal blooms and like fish dying off and things like that. And it's all releasing nitrogen into the water. And then that plus the runoff coming from our rivers, like the industrial rivers, agriculture, waste, water management plants, all of that is going into this lagoon. And then that's all releasing nitrogen and phosphorus into the water. And this extreme excess of nutrients is causing this cycle of, algal blooms that kind of, it becomes super huge in the water that light doesn't penetrate through it. And then once these like big chunks of algae die off, they come sink to the bottom, they turn into muck, and then they keep releasing nitrogen, and it causes this unhealthy cycle that's happening in the lagoon that we're seeing a lot now, especially. So.
Yeah.
Right.
So I would imagine with the different bodies of water, right? I mean, and I've lived in Florida, gosh, 50 years. So, I mean, I know that there's like brackish water and that's where the fresh and the ocean waters are coming together. So I'd imagine when you're sampling, not only it's the location, but the kinds of waters in those ecosystems that then change that as well. Is it likely that all of our bodies of water are being negatively impacted by those things like the runoff? It's not just to a lagoon, which might be smaller, the ocean, of course, all of those things are being negatively impacted by that.
Yeah, so it extends off to a lot of coastal oceans and gulfs. For example, to the Gulf of Mexico, it has the biggest watershed in America because rivers from almost all of the states bordering the Mississippi River and outside of it are contributing to the runoff that goes into the Gulf of Mexico. And you see these giant dead zones where there's no oxygen in the water because they're being consumed by the algae. And so this creates a lot of issues for like fisheries, for scientists to study and things like that. And so we're seeing this in a whole lot of coastal environments as well. So not just our lagoons and our local rivers.
Right. So the farmlands of America are actually fertilizing the Gulf, helping to create some of that problem, aren't they?
Mm-hmm.
Yes. And I know one issue is when you have rivers that near the ocean, they get close to sea level. So the velocity slows down. So you don't have, you get slow moving, you get a lot of settling, right? Everything settles
Exactly.
down. And if it's tidal, right, part of the time the water is moving backwards in an area, right? It's moving, the tide comes in and moves things up the river. So I guess that's just the worst possible scenario if you're trying not to concentrate, things that are harmful.
Is your
Exactly.
as we're talking, I'm thinking about problems with water in general and how we opened up with the idea that you experienced as a child, your family having lack of potable water that was safe, and
Right.
how you ended up here. Do you still have family there, and how do we look at our potable water as being influenced by the work that we're doing with our water systems in general? I mean, are those connected or are those two separate issues?
Yeah, so first I do still have family there. They they still do have some issues, but it has been improving over the last few years. A lot of the research that we do still does connect to this issue of like potable water, even though you wouldn't really think of that at first. Because, you know, the issue in Flint occurred because we changed our water, municipal water source, and then, you know, our pipes began to corrode, and that is because of the lead concentrations in that water. And so this is something that we're studying too in the Indian River Lagoon, is like the concentrations of lead, and if it's the water is like contaminated with this. So we noticed that the water contaminated in Flint, Michigan, when we changed our water supply, the lead was actually above the background level, or above the level that it is safe for consumption. And so that's why our pipes began to corrode and the water began to be unsafe to drink.
So these minerals are found in all different.
Well,
sorts of the
I think
water
it was,
too.
you changed to a source that was either, maybe it was more, it had to do with pH, right? And so the pH caused the lead pipes to leach the lead into the water. You'd think we'd learned from the Roman Empire not to make plumbing with lead pipes, right?
Right, exactly.
Yeah.
So yes, that's the case then. The water was more acidic, and so that's what caused the lead to
yeah, you mentioned changing the source of water, and very interesting. So picture yourself in the future, you're working in the ocean in some regard. What do you see as your ideal vocation when you get out of school?
Ideal location, that's an interesting question. I would love to work on the West Coast, mainly Washington, Seattle, and like Northern California, because I believe I've actually experienced the marine life in Oregon over this past summer, which is super awesome. And there's just a ton of diversity in their wildlife, and their water systems are like beautiful, and they're, you know, they're cleaner, and they're just so much like ability to discover in there. So I would love to go there. Because of the Pacific Ocean is, you know, vast, very wide, and lots to discover there, and also because I do just love the nature of like the mountains and things like that. And then personally, I would love to be traveling a lot for my job. I would love to go to, you know, across the world, really, to Europe, Middle East, Asia, and kind of see what the water is like over there, like how different it is from our research and things like that. So,
but I know that you want to end up teaching, you know, as well with your PhD, right? So that might be something within your research area that you could do. On an aside, my yoga teacher just went to Antarctica, and she was talking to us this morning about the water system there. Like one of the things that, because so few people have actually gone on to the land there, they're very, very particular about making sure nothing is contaminated, because that area is pretty pristine. So they had to like make sure that if they were stepping in the water, which they had to do, these, I guess, were wet landings, right? They had to like decontaminate all of their boots and their clothes before they would go from island to island, because they were very concerned about taking that pristine nature and having it affected by humans, because we've affected, I mean, right, as an invasive species, humans, we pretty much have affected all of our natural habitats. But she was also talking about with the water convection there, and I'm not going to get the terminology right, but it was interesting to think about, because of the way the global warming is happening so rapidly there. The water is actually changing, not only in temperature, but I guess the currents, and because the way the currents work there to release, that's the whole ecosystem happening at the poles.
Yeah, so so this phenomenon is called thermohaline circulation, which is kind of like the deep, it's almost like a conveyor belt of currents that moves throughout the whole ocean. And so in Antarctica, that is where water changes from like cold to hot and hot to cold. And so when we have this effect of global warming happening, where the water temperatures are all rising, we see that the water becomes less cold, as you know, the water overall is heating up. So when the water is warmer, the density is not as heavy, and the salinity and temperature is like, you know, affect the density. So we don't have all of these water parcels moving to the bottom of the ocean. We kind of just have them staying like in the middle, or it's not doing the conveyor belt that it's supposed to do. And so this is something that will change a lot of, you know, wildlife ecosystems, will change the way the currents move. And it's, you know, pretty detrimental if that were to be the case that happens. So
yeah, I had no idea about the way the currents were moving like that. So that sounds like something that you could easily travel the world looking into things like that.
Exactly.
I recall on the tour, you mentioned sort of in passing, but now I'm going to follow up with you. You mentioned
Sure.
something about fossils on the ocean floor.
Mhm.
Could you share just whatever you'd like to share with respect to that? Because I'm very interested in what you have to say.
For sure. So, when we're talking about like fossils in the ocean floor, that is something that's involved in my dream job. It's called paleoceanography, so it's like a combination of paleontology and oceanography. Um, when you take like sediment cores from the bottom of the ocean, you can see a lot of things that you wouldn't normally be able to tell if you just take water samples. So sediment samples are a long-term factor of kind of like the age of the history of the Earth. So when you take these like large sediment samples, you can see, okay, the stratification of the sediments, and you can see the climate was, the CO2 levels were, X in the year 1950, and then they became Y in 2000. So you can kind of see this change of like CO2 levels, and then use that context to be able to determine or predict what it's going to be like 50, 100, 200 years in the future.
Hmm.
And so in these sediments, you also find fossils too. And so, if you use kind of data from other like geological sites and things like that, you can determine, oh, this fossil is, this type of snail. And then you can see, oh, it went extinct at this time in, let's say, the Pliocene epoch in geological time, and you can see, okay, the climate changed, and so the CO2 levels were a lot higher. So then it's like this probably contributed to this species going extinct, and so it's a lot of just like taking puzzle pieces and picking them together, and then until you are able to see like the whole picture, and we can use that just to determine, what our climate is going to be like in the future, assuming that we don't, kind of go the direction that we're going right now. So
Right.
Well, I'm not going to pronounce this correctly, the Anthropocene era, right? With the humans coming in now. And I think that I was
right.
watching a documentary that talked about how when you mentioned that 10-year time span, or you're seeing the differences in the fossils or what things, it's happening at such an exponential rate now, what they're calling this human era, our impact, right? That
Mm-hmm.
even a videographer, documentarian I was speaking with, because I'm doing a conservation unit with some of my students, was talking about how that 10-year span was so critical to be able to see even the development in, say, the Everglades. So the seagrasses that we would have in South Florida and within the Everglades, the change of not only deforestation, the idea of building, right, the habitat decreasing, but the change in all of the availability of those seagrasses that were there before has been
Mm-hmm.
really noticeable and alarming. So it's just happening faster.
It is,
Yeah. A
and
technical question for you about your cores. I know that core samples are like snapshots into the past, whether you take them from
right.
an iceberg, whether you take them from soil or wherever.
Mm-hmm.
Would the rate of sediment, right? So if you're at the mouth of the Mississippi, you can almost in your mind run the camera backwards and see all of that sediment moving back up into the Mississippi.
Right.
So you could only, if you only went down 200 or 300 years, you would see all the impact of the colonization of America, in that 200
Absolutely.
years or so. But in the middle of the ocean, when you're far away from land, are the rates of sediment significantly different? And is their composition mostly organic matter and obviously not a lot of silt? Or do you have things like those puffer things where you have
Right.
thermal events? Could you give us a little lay of the land, as they say, on the ocean floor with respect to sediment?
Mm-hmm. Yeah. So across the ocean floor, there are different types of sediments. Um, in the coastal areas, you get something that's called like lithogenic oozes. So this is a type of sediment that is mainly, excuse me, that is mainly based off of like for minerals, because of like all this runoff coming off from the rocks and things like that. They all kind of like settle down. And then you also get siliceous oozes, which is based off of silica. Silica is a material that dissolves almost anywhere in the ocean because it's so oversaturated or undersaturated, excuse me. And so we see that like, oh, more in the coastal areas, whereas like in the middle of the Pacific Ocean, where you're like meters away, thousands of meters away from land, you're getting more like manganese and carbonaceous nodules. which happened because of the settling of like seashells and crustacean shells, kind of just like once the animal dies off, they kind of settle to the bottom of the sediments, and then they become part of the sedimentation with pressure and
Oh,
things like that from the water. So yeah, you're getting a lot of different types of sediments throughout the earth. And if you look online, like ooze chart or whatever, it'll show you an awesome view of like which parts of the earth, of like the ocean floor, excuse me, have different types of like oozes and sediments. And so definitely when you're taking like a sample closer to the coastal environment, you'll see like a lot more sedimentation from um, newer sediments from like runoff and agriculture and things that we've mentioned. So it's pretty neat to see that kind of difference between the sediments just because of how vast our ocean is. And a lot of us don't realize how deep and how big it is. So, things like that can show that more.
so one of my last questions is this: if you had a chance and you could get in one of those bath escape, one of those deep diving bells, would
Yeah,
you go to the bottom of the Marianas Trench right now if you had it?
absolutely. Absolutely.
Okay,
I
no fear.
would.
That's a very dangerous, right?
It definitely is.
It's hard to imagine thousands of atmospheres of pressure on
Mhm.
a vehicle, especially one that's contained with gas, right? If you drop a chunk of rock, it can't get any smaller, it can't compress. But human lungs, things with gases, they tend to compress.
Yeah, you
Exactly.
mentioned at the opening, like the idea of like, the final frontier, we joke, is space, but many people have argued that's the ocean. So,
Right.
and when you're talking about like the trenches and going down and the difference with the pressure there, what are some of those ways that it is analogous? Is it that the idea that you're exploring uncharted
Uh,
territories, or that you're in different
sure.
environments, or
I'll share a little
Mhm.
bit, and then Nor, you can add the color
Sure.
to the detail. But for instance, off the Keys, they have NASA uses a training facility for astronauts. So one of the things is, once you go down to a certain depth, your body has to be acclimated to the increased pressure, and you can't just immediately return to the top, or you get the bends.
Mhm.
You could
Exactly.
even die. So it's a little bit about being isolated in a hazardous environment where you could die at any minute. Like if something goes
So
wrong,
psychological and
it
physical.
Yeah.
it is about isolation and extreme environment at a minimum, and you have the communication distance where you have to you're not face to face with someone. You can't just
Yeah.
walk into the other room and say, okay, the test is over. So
Right.
that in that way, what would you like to add to that, Nor?
Um, yeah, so definitely, as you said, humans, we have to be super careful when we're going into the ocean. Something that we see in animals, like zooplankton specifically, is that a lot of deep sea zooplankton don't have any gas in their bodies, to protect themselves from the pressure changes. Um, so it's really interesting how, us, like we're so capable of developing all of these, this technology to go down there, but we have to be careful because we're just as susceptible as a lot of these animals are. So when we think about it, like in terms of space, you're kind of like going further and further away from like your resource, which is the earth. So you have to be careful and, limit like your resources, kind of like the movie The Martian, where Matt Damon is like trying to split his potatoes up and things like that. So, you're going further away from your resource and you have to be more thinking critically and thinking, okay, I have X amount of resources, I have to be careful.
Right.
So, it's a lot of mental fortitude just as it is physical.
Sure.
Um,
This movie came out before you were born. One of my all-time favorite ocean movies is called The Abyss. Have you seen that?
I have not actually, but I have heard of it.
Oh my goodness. There's something in it called perfluoron, or it's to accommodate the extreme pressures. They take a liquid that's super saturated with oxygen gas, and you intentionally drown yourself inside a suit, but there's so much dissolved oxygen in the liquid, your lungs can extract the oxygen. So
Oh wow.
that
Gosh, that sounds like waterboarding at its
that
worst.
that liquid, perfluorohexane, I believe is one of the
Hmm.
names of it, is actually used on things like preemie babies, where you lay them on a side and their lungs aren't developed. So you fill up one lung, and babies develop inside an aqueous environment, right? Their lungs are
Right.
full of fluid while they're developing. So that's one of the potential ways that we might acclimate to extreme pressures, is to fill our lungs with
That
fluid. Anyway, I highly recommend you as an oceanographer. Check out The Abyss. It would
I
be a great
shall.
popcorn movie with you and your friends.
Absolutely.
Our last question is always very, very easy. And it's basically just we have listeners who might be interested or who maybe had never really thought about oceanography as an option for them. What advice do you have for our students out there who might be thinking of something along those lines?
Yeah, so if you're a student who loves discovery and loves nature and you're not afraid of being a little bit adventurous and learning a lot of new things, oceanography is an amazing choice for you. I've learned so much about not only the ocean, but just our world in general. And it not only gives you a new perspective on the world, but it kind of gives you a new fondness or a kindness because you're learning about all of these, you know, starting from microscopic animals to the way our oceans connect with like the atmosphere and people in general. Like it all connects together. And so it makes you really like, if you come in with an open mind, you realize just how important this is for us, and if you're interested at all at, environmental science or conservation, this would absolutely be an incredible adventurous choice for you. It's super awesome and I love it. So
We really appreciate you spending some time with us. It really, gives us some time to pause. I think you're right. We are so interconnected, not just as a species, but with the planet, and everything that is impacting one impacts the other. So thank you for what you're doing. We're so excited for you as you head off into your future.
thank you so much. I appreciate this opportunity and I hope, some listeners can get a new view and, look at more about what the ocean is all about. So
Yes, and my last question, would you recommend Florida Tech for potential STEM students of any type?
oh, for sure. The quality of education, especially for STEM, is one of the best at Florida Tech. From what I've heard from students both in and out of the university, and lots of professors are super supportive. And the Marine department especially is awesome. So I would
Thank you.
recommend it to anybody for sure.
Thank you so much for your time, Nora. We really enjoyed our conversation today, and good success to you.
Thank you for having me. I appreciate it.